Hello everybody, D2 here. This is a follow-up video to the Comet process video I did. This is showing a couple other techniques you could use to reduce processing. And then I'm also going to show a different integration technique. You could just avoid the mask method altogether. One doesn't work perfectly for all cases, but a lot of cases it's going to be good enough. And I will show a true to form color image. Had somebody complained about the color I used on the other one, even though it was intentionally green, but I will show how it looks in the natural state. So the first thing is a couple ways that you can batch crop. So batch crop would be done via blank. So I've loaded some subs here. So if we travel down through here, we can see as soon as we get close to the end of the series, by then the artifact is built quite a bit around the side. So what we can do is use the final frame that we're going to integrate as a reference for the crop, and then set the preview. Set a preview in here of your crop. I'm gonna make it kind of like that, and then highlight. You have to highlight all of these, and then hit the scissors. Pick a folder. I'm gonna make a new folder because I've already done this just to demonstrate. Select the folder, and now it's making a crop set. So that's how you do it in blank. Now the problem with that is if you want to use this crop for another image, so say you want to match your star field, you want the same crop because you're like me, you're anal, and you really want things to be exactly where they were somewhere along the path and not move left or right. Or if you're aligning it with another, like a Messier object that happened to be in here and you wanted to have it in that exact spot, then you could overlay it and figure it out and get it roughly where it needs to be. Or you could use a different batch crop method. So let's do the second batch crop method. This one, we're going to open the last image that we're going to integrate of the set. So in this case, it's going to be this one. Last one I took, because it was, if you look at the image, the artifact's building as we get down to the bottom. If I open the first one in the series, or let's open one in the middle, see that the artifact's just starting to grow, and eventually it grows to its maximum right here. This is if you're not doing comet tracking, you're doing the star field tracking. So the star field's moving off the side as you go. So in this case, we would open up dynamic crop, and we would do a normal crop off this frame. And you could also do cropping later after you've integrated everything if you, for some reason, you don't want to trim this out of here. But this is how I did it on this last photo. You'll see it, the final here pretty soon. So drag that off. Now you don't need this anymore. And you have to close dynamic crop to close that. So now we have a template. Next thing we want to do is open up an image container. I right clicked on the background, and we're going to add a bunch of files that we want to crop. Then we're going to drag it onto this process icon. Then it will apply the process template to all of the images in the list. Now there's one problem with this, is the plate solve solution will error, or it will basically try to remove it if you have one on each image. Let me demonstrate real quick. I'm going to add from our Comet registered set, first just one file here just to demonstrate. I'll put an output directory. Let me put it into a new folder. I already did these once, so we'll make another version of this. Put it in here. Just set your output, add your list. Now, when I drag this on here, it's going to complain astrometric solution is going to be removed. So if I had a whole list of these, and I say yes because it doesn't matter, it's just trying to warn me. But if I had 100, 200, 1,000 here, I'd have to hit yes after every single frame is processed. So we don't want to do that. So I canceled that, clear that out, and I'm going to add a few from the beginning so we can see the difference, and a few from the bottom, including the final image. But theoretically could dump them all in there. Now, before I run this, I'm going to edit the source code. I right-click the process icon, hit edit source code, and I'm going down to the bottom. And this only affects this icon. It does not impact the overall dynamic crop module permanently. So this, if I drug off another process icon from dynamic crop, it would start off with this being false. So you set that bottom one to true, close that with a check mark to apply it. And if I were to open that again, you'll see it's still true. And now that's going to suppress those questions about whether or not to remove the plate solve. So we drag this on now, and you'll see there's no error, and it goes about its merry way, processing those and putting them into the source folder I told it. Now we're done. So now if I take back to blank, and let's clear it out, and let's load up the ones I did, which was this, typoed that, comma instead of comet. Comet cropped 2, and load all these, pre-stretch them. I go over here and flip through them. We're comet aligned and we're cropped, the same as before. However, I still have my crop template. And the reason why that's useful is now, if I go from the star image that I made, if you follow the previous video, this is the same star image. This is the same field that the first frame was taken, right? So when we crop this, we're going to get the path of the comet through here. Just same, at some point exactly where it was. This is going to match up. So the main applications for this, if you have a very high resolution camera, say a 62 megapixel or higher camera, even the 26 megapixel like I use, if you have only a small area that you're going to use out of a large batch of subs, and you need to do star exterminator batch processing like the mask technique utilized, or you need to do a lot of drizzle integration, those two processes can take a lot of time. If you don't have a really powerful computer, like mine's a mid-range laptop, it's not super powerful, but it's it's effective enough, that can radically speed up those processes, because they're not having to process all, I'll call that wasted space, where you're not going to include it in the image anyway. So why you want to sit and remove stars and drizzle all of this wasted space? So say you got a small galaxy in a large field view, you could crop and drizzle the center of that galaxy, or the center area where the galaxy is, recombine the drizzle back into a star field that you didn't spend all of the time on. Or for the comet processing, where we'd use the mask technique and star exterminator batch processing, you can do that as well. So the next part I want to show for comet specific is image integration without using a mask, and a couple reasons for this. One is super fast compared to the process with the mask, and the mask is not really needed for a lot of people's photos. It really kind of depends. You'll have to test it depending on how long your exposures are. It can then, playing with the pixel rejection and making that more aggressive, which Adam Block had pointed out that I was going the wrong way with the slider, and I knew I was low on the rejection in general, but lower is more aggressive on that rejection. So a second way to do comet integration is to add your individual cropped images from the step we just did, or use your original comet registered images if you don't want to do it before cropping, or you prefer to crop when you're done. Either way, you pick these. I'm going to use the cropped ones, and I'm going to grab my individual filter. I'll do one filter. So this is how I can select just filter B. Okay, and then same things apply for image integration. Combination average, you don't need to normalize. We normalized earlier on. I'm using Winsorized Sigma. Pixel rejection. This is the one that needs more aggressive. Maybe when you play with this, like 2 worked fairly well for me on this particular set. And then run that. These still have the stars in them. Here we are. Low, it's got minor stuff in it. I should see all of our stars. And then the new image is our comet, which turned out really, really good considering how little time it took. Now you can see this was a major star here. It streaked a little bit. That's going to pretty much go away when we drop the background on this. You could use like SETI Astro's heel on there. You could use clone stamp on that. You could play with sigma levels. You could revert to the star, like the masked version as previously shown. But in many cases, this should work fairly well. And you didn't lose any of the core of the comet. So you do this for all of the rest of your channels and then proceed with the remaining steps for colorization. Now, I did this new method on the comet again. I also did a more natural version of this. I was playing around with green for fun, and it's because it showed up better on YouTube, I believe. But here's a more natural view of this comet. And this is utilizing the crop methods I just showed and the non-masked integration method. And we got good star colors in here. Play around a little bit more with the background, some areas, but a quick first draft of it. My exposures were not very long. I don't have a ton of opportunities to shoot comets, but I probably could have shot some longer exposures to get this tail extension. But other than that, I'm pretty happy with it. So that's it for this video. Hope that is helpful, gives you some more options for comet processing and speeds up processing for other types of images by using the batch crop function. Until next time, clear skies to everybody. Thanks for watching. Take care.